Well, last year I only had one, so they were special. They're the only ones that did it. But this year I have three, so I have to take all of them, right? Okay, so we're going to do related rates problems, but we're talking about problems where the angle is changing now, rather than the other sides. Okay, so we want to find the rates at which angles are changing. In order to do that, you have to recall some information from geometry, was the first time you saw it, and then you redid it in pre-calc. Okay, so here what we're going to use a lot is something called SOHCAHTOA. Do you remember that?
Yeah.
Yes? So for SOHCAHTOA, it has to be a right triangle, and you have to pay attention to the angle that you're referencing. So depending on where the angle is what each side was called. So like if theta was here, which side would be opposite of theta? If I label it, let me label this one as y and this one as x. Which one would be opposite theta?
Y.
This would be the opposite, and this would be the
Adjacent.
adjacent. It's touching, okay? So anytime it's adjacent, it's touching the angle. What would this one be? A hypotenuse, right? Okay. What if I change it now? What if I put theta over here? Now which one's opposite? X, and which one's adjacent? Y. So it's important for you to know that they're going to change depending on where the angle is. Yes? Okay, and when if I told you to find the sine of theta, what would it equal in this case? What would sine of theta be the same thing as? Y over h, right? So sine is opposite over hypotenuse. Do you remember that? So.
Oh.
Yes, you remember?
Yeah.
SOHCAHTOA, right? But I'm always screaming, right? Okay, so SOHCAHTOA. I didn't teach it?
No.
Oh, sorry.
The teacher cannot name.
So, right?
So
So is
again?
opposite over hypotenuse. So that's what I did. Okay. What if I wanted cosine? Coa?
No.
X over
X over
Ga, right? Ga. So ga. What's the a in ga?
Adjacent.
Adjacent. Very good. So cosine theta is what? Adjacent over hypotenuse, right? So adjacent. What's the adjacent angle to theta? Over h, right? Okay, and the last one was tangent, right? So tangent is what?
Opposite over adjacent.
So tangent theta is equal to opposite, in this case y, over adjacent, so y over x. And that one, to remember, we would say what? Toa. Toa. Say it with me. Toa.
What?
Toa. Toa. Good. Okay? So, for these particular problems where we're talking about angles, I'm going to need to know the different trigonometric ratios and be able to set them up, because that's how I'm going to be able to set up my equations that I need to differentiate. Okay, so here we're going to be working with trig and the trig ratios. We're also going to be working with being able to solve these. Anybody remember how to do that?
No.
Oh,
No?
yeah.
Yes.
So like, let's say I had this as a problem. Let's say I had sine of theta is equal to 5 over 4. What would I do to get theta by itself? And this is with a calculator, not without one. How can I get rid of sine to get just theta by itself? Because that's what I want.
The inverse.
I have to use the inverse, right? Remember, when we want to cancel something out, we have to use its what? It's inverse, right? The inverse of something cancels it out. So if I do sine inverse of all of this, right? It's going to cancel it out. And leaves me theta. And what I do to one side, I have to do to the other. So this would also be sine inverse of 5 over 4. Can I put that in my calculator and figure out what theta is? Yes. That's another skill you're going to be needing to do on this assignment. Okay? If they give you something like this, find sine of theta equals radical 2 over 2, you're not going to have a calculator for that problem. You're going to have to know what that is. So what does theta equal when sine of theta is radical 2 over 2? It has to be in radians. Everything we do here is in radians. That's in the first quadrant, you should know it. Pi over 4. Okay, so pi over 4 is this middle finger. Sine is radical 2 over 2. Cosine is also radical 2 over 2. It comes from the what? The unit circle and the hand trick, whatever you remember, okay? You have to know that stuff for the non-calculator problems. The calculator ones, you have a calculator, so you work it out like that. Okay? Cool? Alright, so that's the brief introduction. Let's go ahead and look at part A. Will somebody read it for me?
Part A?
Or the whole problem, because we haven't really read it.
It's not hard. 24 ladder is leaning against the wall.
And like I said, this one is not starting off with this particular stuff. We're actually starting off with just review. We're doing like a ladder problem to begin with. Nobody wants to read it?
Was, but
Okay. Thank you, Alejandro. Go ahead, go.
A 20-foot ladder is leaning against the wall. The bottom of the ladder is sliding away from the wall at a rate of 2.5 feet per second.
Okay. And now read part A.
How fast is the top of the ladder sliding down the wall when x equals 12 feet?
Okay, so let's look at what's changing. So as I push this away, right, what's happening? This is increasing, right? And this rate is what? Decreasing, or this distance is decreasing. What else is decreasing? What's happening to theta? It's also decreasing, right? So if I find the rate of change of theta, it better be what? Negative. If I find the rate of change of y, it better be negative. The rate of change of x is going to be what? Positive. Beautiful. I love it, guys. You guys are doing awesome. Okay, so let's look at this one. What are we looking for in part A? How fast the top is falling down. So we're looking for dy dt. When? When x equals 12 feet. Given. Dx dt equals positive 2.5? Very good, because they're pushing it away from the wall, right? If they were pushing it towards the wall, then it would be negative, because that distance would be decreasing. Okay. What equation do we have to use here to relate those three variables? Pythagorean theorem, right? So we would say x squared plus y squared equals 20 squared. And we can put that 20 in because we know that it's always going to be what? Constant. Alright, so let's do it. Differentiate. Quick. What do we get? 2x dx dt plus 2y dy dt equals 0. Alright, do we have everything we need? No, what are we missing? Y. But can we find y?
Yes.
Alright, let's do it. So I'm going to come over here. We're going to find y specifically when x equals what? 12, because it's going to be changing, but the only one I care about is when x is 12. So let's do it. So what would we end up with? We have this triangle where this is 12 and this is 20 and this is y. Whenever you're looking for one of the legs, it's the difference between the hypotenuse and the leg squared. Right? So we would just say it's going to be 20 squared minus 12 squared, and we have to do the what of all that? The square root. Is it okay that I jump to that step already, rather than show you step by step at this point? Because we've already done a lot of these problems. So that's 400 minus 144, that's what? 256. And the square root of 256 is 16. Well, we're supposed to know our perfect squares from 1 to 20 at least. Okay, that's something you should master since algebra 2. Yeah. But yeah, we all know what happened there. Okay, so y equals 16. Good? So let's plug in. So 2 times, what's x? 12 times 2.5 plus 2 times, what's y? 16 dy dt equals 0. And I'm going kind of fast because these are easy problems. I want to get to the new stuff. So 2 times 12 is what? 24, and 24 times 2.5? Do 24 times 2. What's 24 times 2? 48, and then we also need another half of 24. So what would be half of 24? 12, right? That's just 60, right? So this is at 60, and we're gonna minus 60, right? So we're gonna get the negative 60 over 16 times 2 is what? 32. I already did the work in my head. Is that okay? Moved it over. Okay, and does it reduce? What does it become? Negative 15 over 8. And what would be my units? Feet per second. Beautiful. Super easy? Was it supposed to be negative? Yes. I know I didn't mess up. Or maybe I messed up, but at least I got the right side. It makes sense. If this is positive, then you know you obviously did something wrong. You forgot a negative somewhere or something happened. Go back and check your stuff. Cool? Alright, part B. What does part B want? The ADT, right? So the rate of change of the area. So I'm going to skip all the other stuff and go straight to the equation. What would be the equation for area of a triangle? 1/2. In this case, xy, right? But it would be dh if we labeled it as bh. So, if when we differentiate this guy, we end up with dA dt is equal to derivative of the first, 1/2 dx dt times the second, y. Plus the first, 1/2 x times the derivative of the second, dy dt. And we should know all of those things already, since we did part A, right? So let's just substitute them. So 1/2 times 2.5 times 16 plus 1/2 times 12 times negative 15 over 8. So go ahead and type that in and tell me what the rate of change of the area would be. This is a 2.5, not a 25, okay?
Where is it?
It's right there, right next to you. So, yes, he has his over here.
Okay, yeah, it's like, I did get it. I remember that.
Alright, so what would we end up with? 8.75. Feet squared per second. Huh? How do I do that? Bouncing. The triples. Alright, here's the next part. This is the new part, alright? Now we're going to ask you, how fast is the angle changing when x equals 12? So now the difference here is that we're looking for what? How fast the angle is changing. So here we want d theta over dt. What I'm going to do before I get started is I'm going to draw my picture again here in the back so we don't have to flip back and forth. So theta is here, and they tell us this is 20, this is x, and this is y. So we want d theta dt when, what did they say about x? X equals 12, given dx dt equals 2.5 feet per second. Yes? Alright, so in order to do this part, we need to come up with an equation, right? Alright, so what equation do you think we're going to use? Yes, we need a math equation, obviously. What would we use here? So you want to relate x and 20? Why would you pick those, Ruben? Because of what well, not because of ka ultimately, but because of what? The information we have, right, that we know we're going to use. So I'm gonna use x, I don't know anything about y and I can't figure out y with what I have. So I'm gonna use these two guys, and if I use this, it's what in reference to this angle? Adjacent, and I have hypotenuse, so adjacent and hypotenuse means I need to use what? Cosine, right? So the angle, or the formula will be cosine theta is equal to x over 20. And to make our lives easier, this x over 20, we can think of it as just being 1 over 20 times what? X. So when I differentiate it, it makes it that much easier, right? Okay? So let's work it out. Let's get the derivative. What's the derivative of cosine? Be careful, because remember this is chain rule. So derivative of cosine is negative sine theta times the derivative of theta? No. D theta dt equals, what's the derivative of this guy? 1 over 20 dx dt. Alright. So let's check. Do we have everything we need? Do we know dx dt? Check. What else do we need to know? We're looking for d theta dt. So we don't need to know that. That's what we're solving for. But what we're missing is what? Theta, equalness. Can we figure out theta? Of course, right?